Welcome back to PriceSpot. Today we have a very interesting episode. We're joined by Sarah Kennedy, the CEO of Calocurb, and Dr. Edward Walker, who's a lead scientist behind the development. We're going to talk about a very interesting ingredient here called aromasate, and I think I already pronounced that wrong, so we're going to get into that. But this isn't your typical supplement story, so I'd love to get into the background of you two, and then the origin story of the ingredient, of the product, of the brand, and how you're doing things way differently than anyone that we've really talked to on this podcast. So welcome to the show. Thanks for coming. Sarah, would you like to give your introduction first?
Oh, hi, I'm Sarah Kennedy. I'm the founder and CEO of Calocurb.
Okay, great. And Ed, you could go longer than that. We'll get into some of the backstories. And Dr. Ed, how did this all begin? Can you give us a little bit of your background before we get, because you are not, as I was just told, an employee of Calocurb, are you?
No, I work for the New Zealand government. So as a scientist and a researcher. So I guess my history is that I've always been interested in nutrition and health ever since I was very young. When I was at my undergraduate work was done mainly physiology, biochemistry type work. And then when I got to, after I did my undergraduate degree, I did a postgraduate diploma in nutrition and a master's degree in structural biology. So a little bit of a mix. My PhD was looking at the health effects of berry fruit, so compounds from berry fruit. And one of the learnings from that was that it can be relatively hard to get active components into the blood. So when you're looking at something like a blueberry, it's got all these colored compounds that are wonderfully great, but when you eat them, those colored compounds break down during the absorption process and they tend to not end up in the blood. And so they have what's called poor bioavailability. So learning from my work was that when you're using nutritional compounds, if you're targeting something central, it can be quite challenging. So when I looked to do a PhD, when I finished my PhD, I looked to do a postdoctoral work. I was looking for really stuff that was targeting the gastrointestinal tract. And so I found essentially a project where we were looking for plant compounds to target the gastrointestinal tract for modulation of appetite and food intake. And that's where I kicked off with the research.
Excellent. So all the research, I guess, at what point were you working for the New Zealand government? And I give us a little bit of background on how that starts and how that ties into an actual business endeavor. And a lot of our listeners are going to be more familiar with the FDA and Health Canada. So I'd kind of like to get a little bit of the whole government background over there too.
Yeah. Well, so it started in 2009. There was a call from the New Zealand government, and the reason for doing that was really to look for an option to treat obesity. Right? So we had no good drugs available at the time, so there were no semaglutides, there was no Ozempic. We'd had a couple of drugs withdrawn from market. So there was one called sibutramine, which is changes your adrenaline or epinephrine levels in your brain primarily as an appetite suppressant. And it was voluntarily withdrawn from market in 2005 due to increased rates of cardiovascular issues. There was another drug which you never got in America called ribanicid, which was quite an interesting drug. It was technically an inverse agonist of the cannabinoid receptor. So basically think anti-marijuana.
The anti-munchies drug?
Yeah, well, that's exactly what it did. So it was an anti-munchies drug.
They can't let you have that in America, huh?
The only problem was that that marijuana, people don't consume it for the munchies, they consume it for other reasons, and so they ended up with increased rates of suicidal thoughts being associated with its use. So that was again voluntarily withdrawn from market around the same time. And the only drug that was left was Xenical, which is a lipase inhibitor, so it basically stops your body lipid lipase inhibitor from absorbing fats in your gut. And it was moderately successful as far as a weight loss treatment went, but it really sort of highlighted to us anyway that drugs that targeted the gastrointestinal tract could be safe and effective, and drugs that had more central targeted modes of action, well, I mean, they could be effective as well, but there was much more concern around the side effects you'd get. So we got this call from the government 2009 to develop basically a plant-based treatment for obesity, and we thought, well, okay, let's target the gastrointestinal tract for that reason of safety, also for the reason that plant compounds are easy to get to the gastrointestinal tract. You don't have to absorb it into the blood. You don't have to worry about liver metabolism. Right? And we came up with, I guess, what were a series of studies where we wanted to trigger gut hormones. So we wanted to trigger sort of the major appetite suppressing hormones that you get from the gut, so GLP-1, CCK, and PYY. And we had an idea that essentially using bitterness targeted to the gut was a way of doing that. So that was sort of the, I guess, where it all started, and from there we went on to a research application and got a big government grant of $20 million for 6 years funded.
So when you
just
got
on
that grant, sorry, go ahead.
Just on that, Mike, in New Zealand, nearly all primary research is funded by the government. So we have large government research institutes, and they'll focus. So the one Ed works for is focused on plants, mainly plant-based. They develop a lot of the wonderful apples, kiwi fruit, and a number of other things. We have ones that are focused on agriculture. So probably the difference with New Zealand is we would call primary research is funded by the government, which is fantastic because you imagine, large pharmaceutical companies can do it, but smaller companies can't afford those 10 years of prior research to do these. So, this is where the original origin of this was, and they received this grant, $20 million grant in 2010, and went on to do some quite first in the world research.
Ed, were you working at a specific office or location that was receiving this grant, or where in the government did you work? Do you work for? Could you explain?
Yeah, so at the time the organisation was called Plant and Food Research, and so the way it works really is that it's technically, and it's for tax reasons, it's technically a business owned by the government. So you're sort of off to the side, and what the government did was they set up what are now called public research organisations, and at the time they were called Crown Research Institutes, and they all almost I hate to say compete, but they kind of compete against each other for a pool of government funding. And the reason for doing that is, I guess, the idea is that the competition breeds better ideas. And so we all come up with ideas and we put it together. I mean, the organisation that I've been working for is around 1,000 scientists at the minute. They've just actually merged us together with some other government organisations, and we're now around, I think, about 2,500 scientists with now the New Zealand Biosciences Economy Institute, but at the time we were Plant and Food Research, and so we're based all around the country. So from the North Island down to the South Island. There's also a branch in a few people in America as well, where I believe they do some strawberry breeding work.
Okay, that's cool. So a lot of the stuff that you've been talking about is kind of normal in New Zealand, even though it's different than what we're used to here in America.
Yeah, absolutely. I mean, New Zealand is a much smaller country, and as Sarah indicated, if you've got a big company, a big rich company, they can afford a lot of money for research. If you've got a lot of smaller companies, it's much more of a struggle. And so we've got a few companies in New Zealand that are large enough to pay for big research projects, but for a lot of the time, you simply can't. So the New Zealand government steps in with grants.
So how does the New Zealand government, if you're a company owned by the government, if you guys develop this IP for this ingredient, how does it then go to a company like Calocurb? Can we make that transition here? Can you explain that?
Yeah. So what happens is when they get to a certain stage, so Ed and his group of scientists, they go, hey, we've got something here. This could be commercialized. And then they go out they have business development managers that go out and look for a commercial partner. So in 2017, I was approached by the business development manager, and who had also worked for me before in another organisation, you will find in New Zealand it's not 2 degrees of separation, it's 1 degree of separation. So everyone knows everyone else. So I was approached and said, what would you, because of my background, what would you do with this extract? And I was absolutely blown away by it. I'd never seen something with that amount of science in this larger category, which had these results. And I was just like, wow, this is incredible. And so a bit like the man that loved the product and bought the company, I said, I want it. So then, had to prove that I would be the suitable partner for commercialization. But proved that and raised money, formed a team, and we launched Calocurb in 2018. And I always look back at that time, because you've got to remember that was long before this whole knowledge of Wegovy and Ozempic and all the rest. So really interesting trying to tell or convince people that we're stimulating hormones which will tell them that they're full. And it's kind of like, what are you doing to my brain? And but we were reasonably, we got reasonable sales, but really you can imagine the company took off when Wegovy was launched. I always tell people, it's just such a brilliant product, Calocurb, because of what it does. And they go, well, why don't more people know about it? Novo Nordisk spent in 21-22 $1 billion on marketing. So that was just massive. They took out to dinner and lunch 239,000 doctors. So they basically educated the market. So as I always say, I get down on my knees and I thank Novo Nordisk every day for educating the market on the fact that weight management is a physiological, hormonally driven process. It's not about willpower, which I find absolutely fascinating when people still say to me, oh, it's just willpower. It's not willpower. Our appetite is controlled by our hindbrain, which is a very primitive brain. And we can go more into that because it's fascinating.
Yeah, that's actually exactly where I wanted to go, because it's pretty clear, especially with Dr. Ed, you were talking about GLP-1 like 15 years ago before people were talking about it. Can you talk about like the timeline a little bit of when you learned about this and when it really started to click and how you had something there? Was this all like very well known back in 2009 and we just didn't know, or have you like learned over the last decade a ton too?
No. I mean, the whole approach was pretty. It was pretty novel. So when we wrote the grant, we made it sound like it was quite safe because that's the way you get the government funding. But really, no one had done this kind of research before. So take it back. The whole theory was based on historical usage of bitter foods for regulation of appetite. Right? So if you look, and this is one of the great things about working with plant compounds and foods, is that you can look at the historical usage and that can inform your science going forward. So we looked at what had been used for regulation of appetite. We found that there'd been cultures where you'd had suppression of appetite with bitter foods. So you have in the Kalahari, that to this very day, they take a bitter cactus called Hootia when they're going on a hunting trip, because that will suppress hunger and thirst pangs. In the Highlands of Scotland, they have a bitter Heath pea that they used to eat during times of famine, which was actually, Sarah loves this, but it was also used by King Charles II as a obesity treatment for his mistresses. So he'd give this bitter, not for his wife, just for his mistresses to keep them slim. And so there was this indication that bitterness was used to suppress appetite. But then the Romans come along and they use bitterness to increase appetite. So they used to take a bitter herb infused wine immediately before a meal when they were going to have a feast. And so this got us thinking and saying, well, if it was bitterness on the tongue, then it should really only go one way. It should either be an increase or a decrease, right? Doesn't make sense that it can go both ways. But if it's bitterness somewhere else, then it could. And so we thought maybe it's bitterness on the gut. And when you look at sort of the times at which it's used, so if you look at suppression of appetite as a very chronic, sort of a longer term event, and the stimulation of appetite was a very short term, sort of taken immediately before a meal. And that actually lines up with where the compounds, the bitter compounds, would be delivered in your gut. So if you took it like the Romans did, right before you ate, that goes to the stomach, where there's a pro-appetite hormone, ghrelin. And if you look at what happens in the Highlands of Scotland with the bitter herbs and the hootia and the Kalahari, that's longer term, and you have these anti-appetite hormones down the gastrointestinal tract past the stomach, so the GLP-1, the CCK, and the PYY. And so we came up with a theory that we called the bitter break, which was the idea that if you delivered bitterness to the gastrointestinal tract, past the stomach to where these anti-appetite hormones were, that you would trigger the release of GLP-1, trigger the release of CCK and PYY, and that would suppress people's appetite and stop them from essentially eating. And we came up with really 3 questions we had to answer at the time. We had to answer, were there taste receptors in the gut? So did you have taste buds in the gut, essentially? Because at the time there was no good evidence showing that you did. Secondly, if you did have those taste receptors in the gut, could we basically trigger the cells that have got the taste receptors to release appetite suppressing hormones in the lab, basically do a mini pharma approach where you screen compounds against these cells with the taste receptors and the hormones in them? And 3, can we make it work in people? And so the project was really formed around that idea, with those 3 questions to answer, and we managed to get a $20 million government grant.
That's fascinating. So I got to ask right away, do we have taste receptors in the stomach?
Oh, well, we absolutely do, all the way down.
Or bitter taste receptors, yeah.
Bitter taste
I love,
receptors.
Mike, tell them the story, so that I love the story of how they proved this. Ed literally had to go and hang out in hospitals for 2 years to get these 300 biopsies from people. So tell them about hanging out in hospital for 2 years.
Yeah, so the first experiment we did was basically to say, okay, let's see if these taste receptors or taste buds are in the gut for bitterness. And so we decided to do a biopsy-based study. So we got a gastroenterologist on board, and we basically asked people who were having procedures, so a gastroscopy or a colonoscopy, so a tube in either end, if they'd volunteer pieces of their intestine, little biopsy samples from their intestine, so we could look for these taste receptors. And what happened was we basically wanted relatively healthy people. So we wanted a relatively healthy phenotype, is what you say. And so no one who had a pre-existing gut condition or who was diagnosed with a gut condition after the procedure or who was on medication that alters the gut. Now that's a pretty hard ask because those kind of people don't usually go for procedures. So we ended up with people who were essentially unexplained pain or unexplained bleeding, who'd had their symptoms go away but still come for the procedure. So there were a few of those, but almost all of those people had never had a procedure before. And I'd go up to them in the waiting room and I'd say, excuse me, do you want to take part in a clinical trial? I just need 10 biopsy samples, only 10. And they were just like, whoa, what are you talking about? Never had a biopsy before, thought it was a big deal, and they all said no. The sad thing was most of the people who were there had hundreds of biopsies done in their gut, and they were just like, oh, if they were in the exclusion criteria for the study, they would have said yes easily, but the people I wanted had never had these procedures before. So 2 years later, so it took 2 years, going into hospital every morning, approaching people, we got this sample of essentially all the way down the gut of these biopsies, and what we were able to show was that essentially they're present all the way down the gut, from the stomach all the way through to the rectum. There's 2 areas where they peak. So one's in basically the stomach, what they call the fundus, where the fluid floats in the stomach, and another area is in the terminal ileum, which is when the small intestine changes to the colon, where you get a shift from having sort of not really much bacteria to all of your gut bacteria. And there's sort of 2 points of enhanced requirement to sense compounds, so whether they're bacterial compounds or they're dietary compounds. We also saw that there were a little bit of differences between people, in that there were some people who expressed what you call a full array of bitter taste receptors, so they could pretty much detect everything that was on the tongue. and then but most people had a reduced amount. So technically there are 25 taste receptors in humans, so most people were expressing 17 of them in the gut. You get all 25 on your tongue, and some other people were expressing 24, maybe 25 in the gut. One of them was a little bit borderline. So we managed to find them all the way down the gut. So it was a huge piece of work, but that was the first time anyone had done a comprehensive biopsy study like that for bitter taste receptors.
Okay, awesome. Yeah, go on.
Sorry, I was just going to say, Ed, tell them why in evolution humans develop like that, and why plants develop like that, and why humans develop like that.
Right. So if you're looking at why bitterness regulates appetite, so I guess that's one of the big sort of fundamental questions. So essentially, what bitterness is it's a marker of potential toxicity. Right? So the reason why we have an oral aversion to bitterness is because we're consuming a compound, and that compound looks a little bit like it might be poisonous. Now, fortunately for us, the system is way overprotective. So it's what you call the evolutionary cost of failing to detect something as being a poison if it is very high. But if you accidentally detect something as a poison when it's not, like anything that's bitter, then you just eat a little bit less, so it's not so serious. So we have that system to protect us. Now what plants will do is if you think of, say, an apple tree, it will regulate our appetite and our food intake based on what it wants us to eat. So a plant will get an apple tree, it'll make the apple big and juicy and delicious and sweet, so we'll eat it. But it also doesn't want a person to eat all the leaves that are around it or the bark, etc. So it will actually put in an anti-feedative compound. In this case it's called fluorescein, which is a plant compound which can have a moderate appetite suppressing effect. So that the plants are essentially using this poison detection system that we have and tricking us into not eating. And so that's one of the reasons why we have this ability to detect bitterness, and one of the reasons why we know that plants are very sort of, I guess, active at modulating the system and changing our appetite.
That's fascinating.
Sorry. Go ahead.
Ben, do you want to go?
I feel like Mike and I probably both have a lot of questions here, and I guess like my question to you, because I like you said taste buds, and then you backtracked and you said taste receptors, because we're not tasting that taste in our gut, but we are still receiving it as a signal, correct? Could you explain, I guess, this is probably the opinion here, but like, if we tasted the bitterness in our mouth, why are we still needing to receive that in our gut? Is there the likelihood that we taste something that is poisonous in our gut and we reject it? Like, why does it go that far down?
Yeah. So I think that what it's really doing is that it's lines of defense, right? So against accidental poisoning. So if a compound is very easily exposed, for example, like it's just free floating in some liquid, then you taste it on your tongue easily. Right, no problem at all. Now, if it was bound up and it had some structure around it, so some fiber or something, or some plant compound, some cellulose, then you may not taste that orally. It might be within a cell structure, in which case that would only be detected further down in the gastrointestinal tract once it's broken up. And so the reason for wanting the bitter detection in the small intestine is really because that's when the compounds are likely to be absorbed into your gut. Right? So we have to say, okay, if you've got the compound, if you've eaten it, it's probably not bitter on your mouth because you would have spit it out. If it's got through to your small intestine, your body's saying, well, my only choice is to stop you from eating. Right? And the only way I can do that is by releasing an anti-appetite signal to reduce your appetite. And so that's why your body's triggering that. It's basically saying, we think you've eaten something that you shouldn't have, and our best approach is to reduce your appetite, so you'll then go somewhere else and you'll travel to a different region, and by the time your appetite's come back, that food source will probably not be there anymore. Yeah.
Interesting.
I love this. I also love that how you said it's an overprotective mechanism, because I think about that a lot. We talk about caffeine a lot on this channel, and if anyone has ever had raw caffeine, the xanthine class is very bitter, and so you have to wonder, is my body telling me not to eat this stuff? But then it has so many great effects later on, and they're well-researched effects. It's not just it is a drug technically, but it's not just providing these drug-like effects. There's a lot of really cool health things that are happening. And so I appreciate the way that you kind of explained it, because I think it can kind of help us justify our caffeine consumption sometimes too. So, but anyway, okay, so this then takes us into some of these hormones, I think, and I think CCK and GLP-1 come up. I'm kind of curious, like, so were you very, very well aware of those hormones back then in the scientific community, and then you had to screen for like plants that can cause this to happen, right?
Yes. I mean, we had, I guess, for the project, we had almost what you call an aspirational goal, and that aspirational goal was a gastric bypass in a pill, right? And so one of the things we're aware of is if you do a bypass operation, one of the reasons why appetite is suppressed is because you elevate levels of several gut hormones. So GLP-1 is elevated, CCK is elevated, even PYY is elevated. So we kind of wanted to try to achieve that with a plant-based capsule. So we were very well aware of these hormones. I guess that when you look at triggering them, so they're great appetite suppressors. The challenge with the hormones are that they are relatively short-acting and relatively unstable in the blood. So you have to have a sort of a constant stimulation of them. So there were studies done on particularly GLP-1 where they could show that if you infused GLP-1 into people, so if you got a bag of GLP-1 and you infused it in people over time, you would significantly reduce their appetite, and you could also lead to weight loss if you did that for a long period of time. So we knew these hormones were there, and we knew that they were effective for weight management. It was just really about finding a way that we could trigger them effectively, and we figured that bitterness was probably the best way to do it.
So just from that, after they had proven these taste receptors, and also that they expressed these hormones at different areas of the gut, they then built a high-throughput robotic screening and tested, or Ed, you can talk about that, but tested over 1,000 different plant-based extracts. I'll let you take it over, Ed, because you did the work.
Yeah. So once we had these, we knew that the bitter taste systems are in the gut. We went into the lab. So basically, can we activate these bitter taste systems, these gut bitter taste systems, with plant compounds? And so what we did was we got a cell from the gut. It's called an enteroendocrine cell. And so basically those are the cells in your gut which contain the appetite suppressing hormones. They contain the bitter taste receptors. And their job is basically to take a sample of what's in your gut lumen and to tell your body how to respond. Right? And so, for example, if you have a whole bunch of carbohydrates, the enteroendocrine cells in the intestine, the small intestine, will detect that, and they will release GLP-1 to help you deal with all of the sugar that's released. If you've got a whole lot of fat in your upper small intestine, the enteroendocrine cells will sample that, detect the fat, and they will release CCK to tell your body that it needs to burn fat because it's got a fat source coming in. So we got these enteroendocrine cells, we grew them in the lab, right? And we screened around 1,000 different plant compounds and extracts against them to try figure out what would stimulate these cells to release their appetite suppressing hormones. So the cells we had GLP-1 and CCK in them. You can get other ones which have PYY. It relates to sort of where in the gut you got them from. So anyway, we screened around 1,000 different extracts and plant compounds, and pretty much nothing worked. All right, so it was really hard to trigger these cells. And in some ways it was a little bit reassuring, because if everything works, if you put on anything that was a little bit bitter and these cells responded, then you'd think, oh, well, every time I have a cup of coffee, I should suddenly feel completely full, right? So we ended up with really only 4 possible compounds, or four possible plant extracts, one of which was a potato extract. And it was quite interesting. It was quite active, but it actually contained a toxic glycol alkaloid. So if you've ever seen potatoes, when they're exposed to air, they go green, and you say you shouldn't eat a green potato. Well, as part of that, they produce alpha-solanine and alpha-tocoline, and they're 2 toxic glycol alkaloids, and that's what the active ingredient was. So the potato extract we had was contaminated with toxic glycol alkaloids. And again, that's about this bitter detection system, detection potential toxins. In this case, it was actually detecting a toxin that was a contamination. We then had a barley extract, a barley that was primarily fed to horses, and a kiwi fruit extract as well. And they were active, but they were very small protein molecules, and they just broke down in the gut really, really quickly. So when we looked at stability, they weren't stable. And then the last one we had was a hop extract. And so we really ended up with only one option after all of that. So we had this hop extract. We checked it for make sure that we knew what the compounds were, and the compounds were also standard hop compounds, which have a really good safety profile, so no issues with toxicity. We checked for gut dispersion. So what we found is the extract was like a thick wax. And so it didn't really disperse in the gastrointestinal tract very well, so we had to formulate it with a small amount of excipient in order to allow it to disperse. And then we, basically checked to see what the bioactive compounds in it were. So there was a series of there's probably about 6 bioactive compounds in the hop extract, and we could rate them for efficacy and see which one was the best. And we checked for consistency. So one of the great things about being in a big government organization which has a really, diverse knowledge set, is that we have hop breeding as part of what we do. And we had 10 years of research saying how consistent the expression of the active ingredients were in these hops. So we could say, are you going to get a consistent year-to-year production? And so what was really good is that the genetics of the hop is very stable, and it's not greatly affected by year-to-year changes. So it was within about 2% per year. So we had a really stable, source of the product as well. And so we basically, from that, we got ready to run clinical work on people. But it was, in hindsight, it was quite lucky, really, because we only ended up with one thing we needed to test, and we could have easily ended up with 0. So, yeah.
Especially when you knew that you were going to have a healthy supply chain of it. Oftentimes when we see novel ingredients come into the industry, it's really great, but it's either hard to produce in a commercial way off the bat, and also then, when it takes off in a meteor fashion like GLP ingredients have, then it's hard to keep up with that supply chain. So that lucky is definitely a great word for a lot of the things going on.
Yeah, and I think that it's also one of the advantages when you... so if this was developed at a university, they probably wouldn't have had the same considerations. They would have been looking more at an academic output and more at how biologically active it is this. But we always had a consideration going along that there was always going to be a cost of ingredient, supply chain, etc. And so that always came into it.
There's definitely a lot of inspiration here from an American perspective. I understand what you're saying academic-wise. We go to the International Society of Sports Nutrition show every year, and it's fascinating to see academically-wise what we're producing. But oftentimes, and this is no one's fault, and I don't think it's negative in any way, but there is a disconnect between industry and research. Where, like you said, from an academic perspective, we could be identifying things that are not commercially viable even, it couldn't even get off the ground. So in this case, it seems like it really worked out where you guys kind of understood not just what you wanted to look for and find, but also what parameters needed to be in place for it to be a successful ingredient as well. That can get missed a lot, and then it can be prohibitively expensive to produce, or a lot of different issues can become hurdles.
Yeah, and I think that it's also a challenge with a lot of scientists, in that the way they frame their sort of mind is just not towards that. They're very much about, is this a scientific discovery, and that's why they've become a scientist as well. And so there's a little bit of a reorientation required to just say, okay, you need to just keep your commercial hat on for everything, at least just a little bit, so that you're not wasting your time on something which is really cool but ultimately can't go anywhere.
Ben, you would have liked it this year. Would have been in March. I went down for the harvest of the hops. They're grown in a spectacular area in New Zealand called Motueka, and they had a big they had the harvest, and so they sell these hop extracts all around the world for beer. And so there were 40 brewers from around the world coming for the hop harvest, and me. So, I'm coming from a completely different area. So it was hilarious fun with these 40 brewers. And of course, at morning tea they had beer, at lunch they had beer, at afternoon tea they had beer. And they were a little bit perplexed by, our usage of hops for weight management, as they're drinking their beer. But yeah, so as you said, we use a specific hop variety, but it's a very, as Ed said, it's a very stable supply chain that we can see it growing. We're there, and in fact, they had this incredible hop harvest lunch actually at the farm where we grow our hops.
That's awesome. That would be awesome to see. I know it's beautiful out there too. Okay, so you mentioned that you're getting ready to go to human trials. Did you have any preclinical mouse trials or anything before that, or did you just go straight to humans?
No, so I mean, again, it's an interesting question, and so there's two schools of thought. I mean, I'm quite big on just going straight to people, so I'm not a big fan of mouse trials, and there's a couple of reasons for it. One is that, I mean, for the bitter taste receptors, mice are similar to people, but not exactly the same, right? So they do have a little bit of different sensitivities. Also, I mean, I've done work on mice before, or well, on rats technically, and they're not pleasant experiments to do. And we also wanted to be able to say it wasn't tested on animals. So that's that's a sort of a decision. Again, it's a commercial decision that you can put on your product, not test it on animals. And if you've done just one mouse trial, then you can't. So we went straight into people, and we were able to do that because there was a long history of usage in people. So a long history of hop usage in people, and we could justify safety without doing any sort of animal experiments.
That's funny. I love that. So I'm assuming that the government is still funding these trials. So in a way, you possibly can just ask for your perfect wish list trial. And is that how it works? And if so, so I guess what are the trials that you design? Like, what in the best cases, what would you love to get? What did they end up providing to you, or how did you design it?
Yeah, so we were I guess very lucky in that the project was well funded. So we had a big project with a lot of money, and so we were able to really do at least initially what we call a mode of action study. And so we were saying, okay, if you give this hop extract to people, can you trigger the release of these gut hormones in them? So can you trigger GLP-1? Can you trigger CCK? Can you trigger PYY? And to be fair, when we started, we were really only expecting probably to get CCK, right? Because we had a pill that was targeted to the region of the gut where there was CCK, and we're thinking, well, that's where the hop will be released, and that's the hormone we'll get. So the design of the study was essentially, we got 20 guys. We gave them we cannulated them, so we put a cannula in like you get in hospital. So usually for putting a drip in, an IV in, but for us, we were taking blood out using that. We gave them a fixed energy meal, and that sort of standardizes all of their gut hormones. We then gave them the hop extract, or the Amarasate hop extract, delivered to the upper small intestine, so in a sort of a delayed release capsule, an hour before an eat till their full meal, and then 2 hours later they had an eat till they were full snack. Along that period of time, we took 16 blood samples from them. So a whole lot of blood samples were taken. And what we were able to show was in the placebo treatment group, they had a perfectly normal sort of CCK response. So CCK went up, and then it went down, and then it went up and went down with each of the meals, just exactly what you'd expect. And when we gave the hop extract before the eat till their full meals, they ate around 18% less food at the meals, so we had a big reduction in food intake, but we had an even more impressive increase in the CCK levels. So the CCK levels in the placebo went up by about threefold at a meal. We boosted that up to around sixfold, and we elongated that curve. So we sort of boosted up that appetite suppression, and we elongated it. So it was still following the natural rhythms, but it was higher and a bit longer lasting. And so that was it was a great result. But then when we looked, we also got GLP-1 increases, and almost the same, so same sort of change. So basically doubling the effect from a threefold from baseline up to a sixfold from baseline, and extending the shape of that curve, so making it last longer, and a small change in PYY. And so these were, I guess, really important changes, because when you look at something like GLP-1 or CCK, they have, particularly GLP-1 has multiple functions in the body. And if you want appetite suppression, you have to get around over fourfold from baseline. And that's actually quite challenging to do with a nutritional supplement. So you can get glucose control with lower levels than that, but if you want appetite suppression, it needs to be quite a high stimulation. And so we were getting up to sixfold, and CCK was about sixfold as well. And PYY was a sort of a roughly around, I think it was a 70% increase over what the non-treatment was, so a smaller increase. But we were actually, so we got all three of those hormones. We were only expecting one. We actually had two other projects that were going to try generate a GLP-1 and a PYY response independently, but we didn't have to do them because we managed to generate all three of these hormones with one extract. And again, this was, I guess, this was quite a lucky response, because what we ended up basically finding is that the extract was going into the gut, and it was traveling down the gastrointestinal tract as like a bolus, as like a high concentration bolus down the gut, triggering the hormones as it goes. And that was a combination by the formulation, so how it was formulated, so that it would disperse in the gut enough to sort of interact with the gut surface, but not so much that it would get diluted out. Yeah, so the concentration was very low. It was also likely because the compound is the active compounds are very persistent on the taste receptors. So if you were to get, a Calocurb capsule and you were to break it open and put it on your tongue, what you'd find is that the bitterness will slowly build over around 60 seconds, and then you will not be able to get rid of it for hours. It will sit there and it'll be for hours, and you'll drink water, it won't go away, even alcohol won't wash it away. And so we believe that's happening in the gut as well. So we're managing to trigger, say, CCK and GLP-1, but we're managing to maintain that, activation signal for a long period of time. And we also have very low bioavailability. So we have a very small amount of that extract is taken up into the blood, which means that most of it's retained in the gut, which means it can have a longer term gut effect as well. So we basically did that study, and we had these amazing results. We had an international collaborator on board, and he just said, "Oh, I've never seen anything like this before. You need to look at commercializing it." And so that's really sort of where the real understanding that this was something that could be turned into a product began. After that study, we've done a couple of acute fasting studies where we've tried to make people essentially very hungry by making them fast for 24 hours, with it water-only fast for 24 hours. We've taken them the last 8 hours when their hunger starts to get really intense, and we've given them this hop extract to reduce that hunger. So basically managed to decrease the hunger by 20 to 30%, which is a really big decrease in hunger. It's something that you will certainly feel, and it's the difference between someone saying, "I'm hungry" versus "I'm starving." We've also shown decreases in food cravings, so reducing how much people are craving food during fasting. And we've shown that they will eat less food when they finish that 24-hour fast as well, so their rebound eating is reduced by about 15%. So some really good clinical data. We've also got a study which is being completed, a long-term weight loss study which has been completed, and so that should hopefully be published early next year. And we've got an in-clinic trial as well, where we've been looking at using this product after people come off GLP-1 based injectables to prevent weight regain, and the results from that are really, really excellent. And again, hopefully that'll be published soon.
This is really exciting. We've talked a lot about GLP over the last year, especially from a nutraceutical standpoint and like natural products. And we've talked about support for it through like micronutrients and macronutrients, through like meal replacements. We've talked about muscle and bone support. We've talked about, berberine and, natural alternatives. And for people listening, I'm putting air quotes in here, but it's really kind of compelling that you guys have some data that really actually points to the ingredient being used like kind of in conjunction or around the same population, because typically we're kind of like comparing apples to oranges, even though it is working on GLP. Like this is a lot closer to, comparing apples and apples.
Yeah, I mean, I think as Ed said, what most people don't realise is you need to be over. So we increased GLP-1 and CCK to 600% or sixfold, as Ed said. You have to be over fourfold to make any behavioural change or appetite control. So, the ones we look at, they're like, yeah, we stimulate GLP-1, and we're like, yeah, that's great. But they stimulate it to 65%. So it's not going to, as Ed said, a berberine certainly will help with blood glucose, but it will do nothing for appetite. So we are stimulating the endogenous or your natural release. It's almost like we're super stimulating them. Well, we are super stimulating that release. So its usage, I think, as Ed said, and we're just about to start an in-clinic trial. What I find very exciting is most people don't realise when they've been on an injectable or a synthetic GLP-1 hormone, you have reduced your natural GLP-1 or your endogenous to zero. Now that's quite normal when you have a synthetic hormone. Your natural hormones go, yeah, well, I don't need to do anything. I'm off on holiday now. So they're suppressed. So this is why when people come off the injectables, they get this rebound hunger. They just say your hunger is insatiable and often this weight gain. And Ed, you call it the valley of death, and the fact that you come off, your endogenous is almost zero, your hunger, and you're just going to, anything, the gains you've made, you're going to lose because you just want to eat. And you're just going, and this is why you get this weight regain. So by using Calocurb as you titrate off this, you are reactivating your GLP-1, your endogenous GLP-1. So,
this is really fascinating, and I love the comparison that you made to other hormones. I made a joke to Mike on the side. We always keep notes. When using testosterone, there's a thing called post-cycle therapy, where you are inspiring your body to start creating LH and FSH and testosterone again. And it's the parallel here is, I mean, it's hilarious. I wasn't aware of this after GLP drop in endogenous GLP, but it logically makes absolute sense. Just like you said, our body does not want to create its own hormones if it's getting it exogenously. It's going to be lazy. It's going to let that happen. So do you guys have actual clinical data on getting GLP
yes.
back up? Can you talk about what that looks like, how long that takes, or how that recovery goes?
So we've got the data on that on a injectable, it's reduced to zero, and then we're just about to start a clinical when we're titrating off to show that. So Ed, you can talk to that. That was approved, a month ago?
Yeah, so I mean, post-cycle therapy for GLP-1 injectables is almost exactly what I'd call it as well. So it's a little bit. In some ways, the GLP-1 injectables are a little bit worse because if you look at the genetics behind the GLP-1, it's on what's called a pro gene. So there's it makes a big long pro protein or a propeptide, and so there's GLP-1 on it, there's GIP on it, there's glucagon on it. There's a whole lot of, so around 5 different hormones. So you end up suppressing all 5 of those hormones when you take a GLP-1 injectable rather than just suppressing GLP-1. So you've got sort of 5 hormones depressed. And so what we have essentially is we have data from an in-clinic study which shows that when people come off a GLP-1 injectable, if you give them this hop extract, so if you give them the Amarasate or the Calocurb product, that you can prevent that weight regain. Right? So we have prevention of that weight regain, and as you've probably seen, the data on the weight regain is pretty severe. So you're looking at within a year after people stop the GLP-1 injectables, around a 60-70% weight regained, and going forward to basically full weight regain after 3 to 4 years. Right? So you really need something to do afterwards. So we've got that data that shows that we can stabilize that weight loss when you titrate people off. So if people want to get off a GLP-1 injectable, it's a really great option, and probably the only option currently. The other thing we're doing right now is we're taking blood samples of people who are, when they're titrating off. So what we're asking is, why are we able to prevent that weight regain? All right, so why can we stop people from weight from coming back up? And we think it's because we're basically telling the body to produce more GLP-1. We're giving a GLP-1 stimulator, saying those cells, you need to start responding, produce your own GLP-1, so that when people are titrating down on that artificial injectable GLP-1, their endogenous is being kick-started by the product. So think of it like, exactly like a post-cycle therapy for a testosterone user. And so we're measuring that. So we're measuring GLP-1 recovery post GLP-1 injectable with and without the Calocurb product to see if we can show a difference.
So we've done
That's awesome.
the weight, the no weight regain, as Ed said, but this next one is doing the measuring the blood. So we'll actually have exact blood measurements.
I love it all. Okay, so I want to reiterate when you mentioned 600%, like there's statistically significant and then there's clinically significant. So that's what I love seeing is we need some smashing numbers like that, and clearly seems like it works. So you have this trial. How do you figure out? First off, I'm sure someone in the government or some board had to approve that this can go to market or this can go to someone like Sarah and get commercialized. So I'd like to know a touch about that. But then also, how do you decide what dosing to use? Especially if you don't have any like animal data or anything.
Yeah. So I mean, so just between us, what scientists tend to do is we tend to give it to ourselves and see.
Absolutely, that's hilarious.
So one of the reasons for the formulation with the excipient was that when we first got the extract, we decided to take it ourselves. So we got the extract, put it in a capsule, and tried it, and we're like, oh, didn't really do anything. And we tried it again, didn't really do anything. And then one day we realized that we were essentially pooping it out as just a big waxy glob, so it just was not dispersing in the gut. And so it was only really by taking it ourselves that we figured out that we had to add an excipient to allow it to just disperse enough to interact with the gut. Dosing's tricky, yeah. I mean, you're absolutely right there. And essentially that's what we did. We just took it ourselves until we felt it. Yeah, so just up regular, and it's one of the things about being a scientist. We knew that the safety profile is really good. So the worst that we were going to experience were some acute gastrointestinal upsets. If we managed to stimulate our hormone levels really, really high, then we might feel bloated or get a bit of diarrhea for an hour. And so there was no real risk for us. So we really just dosed it up ourselves. As far as the commercialization goes, yeah. So it was a process. So there's always a struggle in these government organizations between doing that fundamental science and doing that applied science, and also getting someone who understands when something's, I guess, suitable to be applied, suitable for commercialization. And so we had, in my organization, we employed commercialization managers. So at the time we were doing this research, we started employing these commercialization managers, and their job was to go through all the science that had been done and to say, is there a commercial application for this? Yes, no. If there is, what do we need to do to take it to market? And so that's really what's happened then, and it's what happens now. So that the organisations have changed over time, and they're much more output focused now, or impact focused for commercial gain. So they're charged with benefiting the economy of New Zealand. So that's one of their key performance indicators. And so really that's what happens now. And so we do a mix of that kind of work and also work supporting businesses. So if someone's got an idea and they come to us, so it's not always our ideas, but if someone comes to us, how can we support that the best? So can we tap into some government support for their work in order to help grow their business?
That actually is one of the questions I had written down from way earlier is when it seems like you have a lot of talent over there and some cool strategies and ways of doing things, is it possible to commission any of these New Zealand research organizations to do work for the supplement industry outside of like some of this stuff?
Absolutely, yeah.
Can we hire you?
Absolutely, you can hire us. We've got a great lot. And it's not just me. There's lots of other scientists who are in these organizations, and I guess we're a little bit unique in that because we've got that little bit of a commercial hat on at the same time as the scientific one. We tend to be a bit more focused on, is this going to achieve the outcome required for the commercial partner, right? Rather than is this going to get us an interesting scientific output that gives us a great publication for our academic career.
Gotcha. Okay, so Sarah, let's talk about commercialization then. I'm not sure they kind of approached you. I'm not sure if you had to pitch anything, but in general, it's 2017. You see this thing and it's like, wow, this is really going to work. How do you launch this product, especially back then when like 99.5% of the public had never heard of GLP-1 or CCK or a lot of this stuff? So what was the game plan? What'd you do? And tell us a little bit about that.
Yeah, I think a founder, you've always got to have a personal story. And when I was presented this, as I said, I'd never seen that amount of science in that larger category. So I was absolutely, I thought this was incredible. And also having, during my life, having had, and I think a lot of people do, this love-hate relationship with food, loving it by hating it, binging, dieting, and so on like that, that when I then was presented it, and of course started taking it, it was just a game changer. And I've been on it now, 7 years, and I don't take it for weight loss. I take it just to quieten the noise in my brain and to help me. I can walk past those muffins at morning tea and things like that. We are surrounded by food. So, loved it with that. So, that's what says I think, I know I can make changes in other people's lives. I don't know. I think you've got to be slightly mad to be a founder. I was just so in love with it. And so, as I said, I raised the money. I formed a company, raised the money, and formed a team. And literally we launched, I think it was the 3rd of April. It wasn't April Fools. It was the 3rd of April in 2018. We launched in New Zealand, and we launched direct to consumer first, and literally a month later we launched in the US direct to consumer, so all online, using KOLs, everything like that. As I said, we certainly got some traction, but it was hard work trying to. People just didn't understand the etiology or the basis of weight management. It still came back to, willpower. Why don't you have willpower? It was extraordinary. So we battled away, but during this time as well, we continued to do clinical trials. So as Ed said, we did the fasting trial in males, and then we went on and did it in females, and then kept getting more and more science data with it. And then, as I said, in 2021, when Wegovy was launched, and they just educated the market. And we decided then we would start targeting the practitioner market in the US. And that would have been just after COVID, so that would have been 2023. Because remember, we weren't allowed out of the country for 2 years. We were like that song, we could leave but never come back. So we didn't leave till 2023. And I remember we went to an obesity medicine conference in New York. And it was really a test to see if the practitioners or doctors would accept our science. And the first day we were there and set up our little booth and everything, and we were just overwhelmed by doctors, just overwhelmed. I literally could have sat on the floor and cried. They got it. They got the science, they got the clinical trials, they accepted the product. And so that was really, for us, that move into the practitioner market. And that was really early on because, they were just receiving these injectables and they had coupons and everything to get people on, but they weren't thinking about coming off. So really, since that time, we've just continued to grow and really focused in that practitioner market, because it acts as a halo effect into the consumer market.
Okay, so yeah, that's incredible and very fortunate and everything. So what is the general discussion with the practitioner? I assume a lot of people are coming in asking for Ozempic or Wegovy or any of the newer drugs too. Are they oftentimes presenting this as the post-cycle therapy, or are we sometimes offering it as an alternative, or what is the story that's being told?
Look, there's multiple usage, but there's really three. As an alternative, and that's if people A, can't take the side effects, which are pretty hard, B, don't want to inject themselves, or C, can't afford it. So look, here's an alternative. And I'll just give you a comparison, because most people say to us, and Ben, you said apples and oranges. On a semaglutide, the average reduction in calorie intake is 25% per day. On Calocurb, as you know, the average is 18%. So not as strong, but it's in that comparison level. So it is an alternative. Really interesting, a lot of practitioners are using it in combination, because in combination they can reduce the dosage right down. So say it's a tirzepatide, they can use it at 2.5 mils and just keep it at 2.5 mils rather than bringing it up to the 10 mils. And what, of course, you're doing with that is you're reducing the side effects quite significantly, and also you're reducing the cost for people, because something that would have lasted a month can now last 2 months. And of course you're giving exogenous and endogenous, so you're keeping a natural cycle going. And then, of course, the third one is the post-therapy, or the titrating off. And I say that's not an if, it's a must. You must be giving it. So those are what, we are really talking about. But, there's wonderful applications in peri and post-menopause. There's great applications in premenstrual and PMS. There's all of these protocols that we're talking to practitioners about.
Yeah, GLP-1 alternative is like a really hot button topic that ever since the beginning, we've been really nervous to use those types of phrases, because while we can talk about the pathway, comparing them head to head has been difficult. So I think that a lot of people who hear, some of these injectables can reduce eating by 25%, and then you say 18%. Well, that's not as much, but first off, people don't need to inject it. And that right there, I think that is the biggest hurdle for GLP drugs, is that most people don't want to inject themselves with things. And so the fact that you have an easier path of consumption that people can stick to for longer, probably, that is really nice. But I like that you mentioned the thought of using them together, because that way you could use less of the medication, possibly lower some of the side effects, and use something else that can keep the endogenous production of it elevated, or at least more normal than you would be if you were shutting it down with an exogenous hormone. So I love all of these discussions. I'm really excited to talk about this and blast this out to people, because this discussion's been pretty constant. We talk about a lot of products that are starting to make claims on GLP, and we've been kind of telling everyone to pump the brakes a little bit, because we got to be realistic and we need to have head-to-head content or head-to-head data. And this kind of really answers a lot of those questions.
Ben, the other thing we get asked, which I'll let Ed answer, but is if you stop Calocurb, is it like a GLP-1? Are you going to go back? This incredible hunger, and and what Ed can answer this, but I do it very simply in saying we think we upregulate the production, so we're actually improving the gut-brain axis. And my very simple explanation is I'm exercising these little receptors all the time, so I'm making them stronger. But Ed, I know you look absolutely disgusted when I talk sometimes, so I'm going to hand it over to Ed.
Yeah, so the indications are that there shouldn't be a rebound, and the reason for that is, well, really at a fundamental level, I think that for our modern lifestyles, we have a gut and a brain that don't communicate very well, right? So through diet and through exposure to environmental toxins, etc., we're getting our gut signaling reduced. And what Calocurb or Amarasate is really doing is it's teaching your gut to talk to your brain again, and part of that is increasing the number of enteroendocrine cells, these tasting cells you have. And we certainly see data that when you're exposing your gut to enteroendocrine cell inducers, so compounds that will trigger the enteroendocrine cells, that the long-term response of that is to increase the number of those cells you have present, which means that you're more able to release these gut appetite regulating hormones. And so just like Sarah says, it's really like you're training your gut to talk to your brain again, to tell it that you're full, to explain to it that you've had food and you don't need to eat anymore. And so we're very confident that people don't suffer that what I call the GLP-1 valley of death when you go off a GLP-1 injectable, that you've essentially just trained your body to be more responsive to food, and that if you ever feel like you need to come back onto the product, you can always do that as well. It's a very easy on-off system, and you can just take it on the weekend if you want. So there's a lot of flexibility too.
I love it. Yeah, there's a lot going on with the lowering the dose. That's been a thing I've thought about a lot, because some of these drugs seem to work so well. My thought was always like, why not just take less of it then? And a lot of people are getting into the microdosing protocols, but with the microdosing, it seems like you would want to have a little bit of strategic support on the side, and it's kind of the best of both worlds for those who are really going down this path and everything. So I commend you for what you're doing, because I think that's going to lead to just generally better outcomes for nearly everyone and everything. So I think it's all fascinating. This is really cool.
Yeah, and if I can comment on the microdosing, I think one of the feedbacks we get from clinicians who are using what you'd call, I guess, a microdosing or a lower dose in combination with Calocurb is what they find is that if they start lowering the dose, then they get breakthrough hunger towards the end of the week. So they get through to, like, if they take it on a Monday, the injection, by the time they get to Friday, they're starting to get hungry again. Whereas if they're combining in the Calocurb product, they're able to prevent that breakthrough hunger. And so that's really what they notice, is that it allows them to essentially microdose once a week without suffering problems with breakthrough hunger.
Gotcha. And so one of the things you've kind of talked about a few times is the excipients and everything. Are you willing to discuss what you're doing in there, or is that part of the IP that you can't kind of share?
I don't know.
I know that there's capsules out there that are kind of fancy and everything too, with some of our friends. I'm not sure if this is what you're using or what you're doing.
No, well, I'll let Ed talk to it, but it's very simple. We only have 3 ingredients. We have the Amarasate, and once again I'll say Amarasate. The scientist named it Amarasate, which is Latin for amara being bitter and sate being satiation, which is fabulous when you're in the lab, Ed, but no one else in the world can pronounce it. So, I inherited Amarasate, but it's Amarasate. But as I said, they needed to put in an oil or a vegetable oil to help this dissolution of it, and then rosemary is there as a natural preservative. The vegetable oil is canola, and it is GMO free, glyphosate free, all the rest, but I'm going to let Ed talk to that because we get asked all the time.
Yeah, so we had to add, well, for starters, I mean, I don't think Amarasate's an issue. Did everyone else not take Latin at high school? No, so anyway.
I wish I did. Over here in America, we would just respell it to A-M-E-R, Amarasate, and then we'd. But
there we go.
It's all yours.
We'll talk to the trademark people about that. Yeah. Yeah, so what we found is because we had that thick wax, we had to add a small amount of oil to it, and I guess it's a very small amount, but it's always a complicated decision there. And so really we went for what we wanted was an oil which was stable, so primarily monounsaturated. We wanted one that had relatively high levels of vitamin E, so again that was to help with stability, and one that had low levels of other plant compounds. So you could sort of think, oh, well, what about olive oil? Well, the challenge with olive oil is, one, it's very inconsistent between production runs, but also it has a lot of other plant compounds in it which can potentially, I guess, interfere. And so we just chose an oil which was inert, stable, and had, little interactions. So there's basically just a couple of drops of canola oil into each of the capsules just to allow it to disperse.
Okay, great. Thank you. Oh, and then you do have, and then you do mention on your site, so I'm going to mention it, you have a Lonza patented capsule. So this is a soft gel, though. I was going to say, are these DR caps? Because we've talked about those before, and we're going to be podcasting with Lonza pretty soon at Supply Side Global. But these are soft gels then, right?
No, these are delayed release LiCaps. So the LiCaps are a patented capsule where they're basically a hard gel, but you can put a liquid in a hard gel. So they've got a band around them. So if you get a delayed release soft gel, you've got to put some pretty nasty chemicals on them. So you don't want that. So this delayed release LiCap, LiCap really, and then it's delayed release, is manufactured and patented to Lonza. So we grow the extract in we grow the hop in New Zealand, we extract it in New Zealand, and I think that's important to understand because people say, well, you've got phytoestrogens and hops and so on like that. We use CO2 supercritical extraction, so it extracts all of the everything except the alpha and beta acids and a small amount of essential oils, which I will say, guys, don't mind that, because if you get any reflux, it's like a bear burp. So they're like, oh, yeah, this is okay, I've got a bear burp. So no phytoestrogens, no biological materials. That's why it's like a thick wax. So we grow it, we extract it, and then we send it to the US where it's manufactured in Lonza in North Carolina.
Awesome. Okay, and so if you're just someone not worrying about a GLP-1 drug or any adjunct therapy or anything, and someone just wants some appetite suppression, what is the general go-to dosing strategy? It's 2 capsules per day. Like when am I taking it? When am I not taking it? Any suggestions?
Sure. So what we'd always say is you always want to take it on an empty stomach or empty-ish stomach, because remember, you want it to go through to the upper gut. You want it to bypass the stomach. So take it. So we always say take it, it's not hard and fast, but take it an hour and a half before a main meal. So lunch and dinner. It depends on what you're trying to do. But if you're looking at weight management, take it an hour and a half before lunch and in mid-afternoon for dinner. It doesn't have to be exact, because remember, it lasts for 4 to 6 hours as it travels down the intestinal tract. And as Ed said, we got, after that fasting trial, when we did a rebound eating, we got 15% less intake, and that was 4 hours after their last dosage. So we know it lasts for 4 to 6 hours. So we try and make it easy for people, but an hour and a half, whenever you take it, it will stimulate it. And so twice a day. I intermittent fast, so I take mine at about 9 o'clock in the morning, or 8 or 9 o'clock, just whenever I remember, because that'll take me through to 1 o'clock for lunch, and I won't eat as much. So, there's degrees of how you use it. We do have an onboarding of a week, because interesting, it's 1 a day for 2 days, then 2 a day for 2 days, and then up to 2 really small capsules twice a day. And why we're doing that is, I think as Ed said very early on, remember there was that small percentage of people who were the super tasters, that had the 24 to 25 taste buds right through their gastrointestinal tract. So some people are going to be more sensitive, and they may just be able to take one capsule. And you will know, as Ed said, where your dosage is, because if you've had too much, and you may get in the very early on, you'll get a laxative effect. So, a lot of people don't mind the laxative effect. So, it's that's why we have that onboarding for a week.
Yeah, and that's posted on your science page at the bottom. I see a cool graphic. I'll try to get that into the show notes here where we have links to the studies and everything else. Okay, that's definitely helpful. This is incredibly interesting. I love the whole story behind it. Are there any additional comments to add or anything that we may have missed? I feel like we've gotten the story, we've gotten some of the mechanisms, we have your clinical studies, how to use the product, even the capsules. What am I missing here? We have any other comments?
Well, the only one is, and probably this is for Ed, has been working on for the last 2 years. We've done incredibly large, actually the largest trial that's ever been done in New Zealand with a supplement. So we've just done 150 patients, men and women, using of placebo and Calocurb over 6 months with a 3-month follow-up. And number of biomarkers, there's weight, there's body conformation, there's bloods, help me out Ed, GLP-1s, it's a big trial.
As well, yep.
Yeah, we raised on that, so we spent over $2 million on that clinical. It's just finished, and it's going to be unblinded by the end of this year. So I can't believe it, Ed, it's 2 years later. And we're nearly at the end. So we'll have those results early in the new year, which, yeah.
That's exciting. Okay, you definitely contact us when that comes out. We'll want to provide some coverage and link it in and everything, and break the study down if we can get the full text.
Yeah.
To everything. Excellent. That's great, Ben.
I guess I have one last question here, and this is probably the most uncomfortable question to ask you guys, but as someone from our industry, I have to ask is, you guys only sell this direct, and we're going to have a lot of people that are super interested in using this. And even just during this conversation, just as a formulator, I'm sitting here thinking of all the things that it could work well with. Why don't you guys let people formulate with it? Is that a government decision or is that a company decision?
Well, I think it's a company thing at the moment because our main goal was to always, we've had 15 years and 30 million in research so far. So the whole thing is to build our brand first and to continue building our brand. That's not to say in the future, I'd get approached on a daily basis for that. So that's not to say in the future, but at the moment it was really to build the Calocurb brand. And, as you said, when we started 7 years ago, no one was interested. It was like, yeah, what? I don't know. So now, it's building that brand.
Yeah, we very rarely recommend people do this, but you guys have done a wonderful job of building it and really investing in the science behind it, which is in some ways a lost art or maybe something that most people don't appreciate enough. So thank you for the work that you've done, providing data that our industry can look at and appreciate. And especially with this like GLP phenomenon, you guys have given us a lot that we can talk about, where a lot of other companies are kind of relying on old data that isn't necessarily apples to apples. So definitely a big thank you. I'm excited for this conversation to develop more.
Thank you so much.
Okay, and last, where can we follow you? Calocurb.com. We'll have links to that, of course, and I assume it's Calocurb on social media. If you're active on any social media channels, let us know. Even LinkedIn, we have a lot of people in the industry going there. So where can people find you, if at all?
So, you can find us on, www.calocurb.com. We're on that, and then on LinkedIn as well. We're on Facebook. We're on all of the channels, and we have. You said we have 4 values in our company. The first one is science-led. So everything we do is science-led, and as we're partially owned by the government, we have to be. Also, I'll get a slap, won't I, Ed? What I do anyway. The second one for us, our second value is customer success. So everything is about customer success. So if you have any questions at all, there is a direct link, and you'll be answered literally within 4 hours with anything on that. The third value is simplicity, which Ben probably goes a little bit to your point. We grow the brand. And then the fourth value is a passion with integrity. So, I hope you see that through the science and everything we do and what we say. We're very passionate about it, but everything we do is clinically based. So, yeah, really exciting. You can follow us. And as I said, you can ask us any questions and we get back to you literally. And if they're too hard for us, they go straight to Ed.
I love it. And are you on Instagram or TikTok or anything like that? Showing some science?
Yeah,
Well,
we're on Instagram. We're on Instagram.
Well, I'm not personally on them. I think I have a LinkedIn page, but maybe one day when Sarah stops making me spend all my time in the lab doing science, I'll start doing some social media stuff.
Yeah, I always jokingly ask the scientists because almost universally you're not going to be posting Instagram selfies, so that's just how we are.
Yeah.
Excellent. Well, I would like to thank you so much. If you have anything else to add, then please do so right now. Otherwise, I've got a great amount of information here, and I love what you're doing. I love the fact that you're increasing GLP-1 by 600%. I think that's incredible, and we would love to see this ingredient more places. But for now, calocurb.com is where it's at. So we appreciate it.
Thanks, guys.
Thanks very much.